In this video, we're going to look at one more example of single factor analysis of variance hypothesis testing. In this example, we have a company that has developed a new filtration system for municipal water supplies. And they want to develop the best possible assembly method to produce these new filtration systems. The industrial engineering group who was responsible for this task have developed three alternative methods of assembly, method A, B, and C. To test the productivity of these three different methods, they selected 15 workers at random and then in a random fashion assigned 5 workers to method A, 5 to method B, and the balance 5 were assigned to method C. So the workers were trained in the method they were assigned to, and then the production per week of each employee was recorded. The objective is to determine which method produces the maximum number of filtration systems per week, or if they're all the same. So here, the factor in this case is the assembly method. The treatments is the three different alternatives that we are considering. The response variable is production number of units assembled by each employee during 1 week period. The experimental unit is workers producing the products. The type of study, so in this case we are randomly assigning the experimental unit, that is the workers, to each of the three methods of production. Therefore, this is an experimental study. It is not an observational study because we are not observing the workers who are already working in these assembly methods, but we are consciously and specifically randomly choosing workers and assigning them to the different production methods. And therefore, this is an experimental study. Now some notations. So we have 3 assembly methods. So population 1 is the production per week for workers assigned to method A, and population 2 is assigned to method B, and population 3 is assigned to method C. Some more notations. So we have mu sub 1 is the average or mean production per week by all workers assigned to method A, and mu sub 2 is same average for all workers assigned to method B, and mu sub 3 is all workers assigned to method C. Now we have variance of the 3 populations, method A, B, and C, and of course later we're going to assume that these 3 variances are all equal for us to be able to conduct the hypothesis test. The hypothesis is that the 3 means are equal and H sub A is the 3 means are not equal, or at least one mean is different. Now the assumptions that we have to make: the weekly production follows normal distribution for each of the 3 methods. The variance of weekly production is the same for all the 3 assembly methods, a common variance of sigma squared. And the workers' weekly production using the 3 assembly methods are independent, or samples are independent. Then we have 3 samples, 1 for each method, and they are summarized with sample sizes n sub 1, n sub 2, n sub 3, sample means x bar sub 1, x bar sub 2, x bar sub 3, and sample variance s squared sub 1, s squared sub 2, s squared sub 3. Now at this point, the procedure is exactly same as the first example we did, that was the observational study. Now we construct an ANOVA table and we complete the test. We'll do that in the next video.